Hi guys, we are students at Imperial College London and we're studying MSCI. I'm George.
I'm Lorenzo.
I'm Charles.
I'm Yoanna.
I'm Toby.
I'm Ahmed.
Our project is tackling Crohn's disease using deep learning, supervised by Dr. Bernhard Kainz. Currently, there's lots of research getting done in medical imaging to aid all sorts of diseases. But there is the problem that there are very few options to make the algorithms accessible to clinicians because of a range of technical or regulatory issues. Our team did a proof of concept of deploying a machine learning model for a clinician, implemented and tested for a particular disease called Crohn's disease, which is an inflammatory bowel disease, and it affects a region called the terminal ileum particularly badly. We were supplied with a ResNet model, which automatically diagnoses the disease. With this model, we had the following vision for the flow of the product. A clinician would come in and upload the scan and select where the terminal ileum is on the front end. These, the scan, and the coordinates would be sent to the back end, where they would be pre-processed, and then the model would be queried. It would then give a prediction and heat or attention maps to aid interpretability of the model for the clinician. Those would be post-processed in the back end and passed back to the front end for the clinician to see. Now we're going to show you a demonstration of what the product looks like.
We are now on the user interface of our product. It contains instructions on how to use the application, a section that allows to upload an image that should be analyzed, and a medical image viewer that we see here. I'm now going to upload an image to the medical image viewer, and to that end I simply drag and drop the image of interest to this box right here. It's now being uploaded, so note that we can upload nifty, so .nii or .nii.gz files, and the upload is now done. And it allows us to navigate through the image, so by clicking on different parts in the axial view or in the sagittal view or in the coronal view, and we can of course change these views by swapping them. Now the coordinates are shown at all times at the bottom left here. Now the product was developed to return a prediction as to whether a patient suffers from Crohn's disease or not. And to that end, the first step is to have these blue crosshairs at the point that belongs to the terminal ileum. Now I do that, it's here. And if I want to get a prediction, all I have to do is click on Get Prediction. So we now have a prediction. And it tells us that this patient suffers from Crohn's disease with probability 0.863. And at the same time, it tells us why the model thinks so by returning these heat maps. Allow us to show which parts of the image led the model to its prediction. So in this case, it would be this white region here. And if we want to see what hides behind this overlay, we can simply change the transparency up here. Now we see what hides behind. And if we want to get additional predictions without every time generating these heat maps, we simply untick this box here. Again, click on a point that belongs to the terminal ileum, so right here, and get a prediction. We can now click on multiple places and get predictions. And you will notice that these coordinates, they are recorded here in a history of coordinates. So if we want to return to an old point of interest, we simply click on them.
So we're currently testing this product with clinicians. However, the scope of it goes way beyond Crohn's disease. What we've tried to do is bridge the gap between the availability of machine learning models to clinicians and their actual use in industry. In our framework, any model that uses medical imaging for diagnosis can be swapped for the current Crohn's model.